Welcome to this session on building smarter chatbots with intelligent search. I know we're all busy people, so I really appreciate you taking the time to watch this session. My name is Sarah van der Moosdijk, but most people call me Moose. I'm a machine learning specialist partner solutions architect at AWS based in Australia. There are a couple of things I want to cover in this session today. We'll start by looking at a case study to understand why we might want to add intelligent search capabilities to a chatbot. Then I'll dive straight into a demo, and I'll show you a bot I created to help you navigate the agenda for AWS Innovate this year. After the demo, I will quickly introduce the 4 AWS machine learning services I use to create the bot, in case you haven't heard of these before. If you're already familiar with these services, I'll provide an overview of the most recent announcements, which you may not be aware of yet. Finally, I will dig into the technical details of how I went about implementing the bot with intelligent search. Please note that this is a technical session, and I will spend most of this time showing a demo and talking about how I implemented it. I am going to assume that you already have some experience with AWS. So let's first look at a use case for a chatbot with integrated search capabilities to understand why this is useful. Citibot is a technology company that builds AI-powered chat solutions for local governments in various US states. With citibot, local residents can quickly get answers to city-related questions, report issues, and receive real-time alerts via text responses. The company built a chatbot to handle basic call queries, which allows government employees to allocate more time to higher-impact community actions. Unfortunately, with COVID-19, Citibot call centers saw a dramatic uptick in wait times and call abandonments as citizens tried to get information about virus prevention and unemployment insurance. So, to increase the flexibility and robustness of their chatbot to new situations, like a global pandemic, Citibot wanted to add search capability. They engaged Tensor IoT, an AWS advanced consulting partner, to add this functionality to their bots. The team at Tensor IoT built a web connector tool which enabled Amazon Kendra, our enterprise search service, to index relevant web pages on COVID-19. By integrating this new functionality into the chatbot, Citibot saw wait times reduced by up to 90%, and the number of interactions handled by city officials decreased. This allowed municipal governments to focus their energy on initiatives to keep their communities safe. So, I hope this case study helps make it clear how chatbots can be improved by adding the capability to search over large amounts of data. A chatbot is usually designed to help customers with very specific problems and queries. For example, a chatbot might help a customer book a flight or order a meal. The context is constrained, so if a customer is booking a flight, the bot would need to know about the different types of seats on an airplane, the meal options, and the departure and arrival times. But the chatbot is not expected to know what the best sushi restaurant is at the destination. By adding the ability to search over large collections of documents, we can extend the scope of the chatbot without needing to spend a lot of time on predicting and designing the customer interactions. So instead of predicting what customers will want to know about COVID-19 and designing flows to handle each question, it was easier to provide users with access to a large collection of knowledge on the topic through a chatbot. But really, the best way to understand how a technology can add value is to look at a working example. So let's take a look at the demo I've built now. Here, we are looking at the public webpage of AWS Innovate AI/ML Edition for the Asia-Pacific region, which is the event you're attending right now. The webpage provides an overview of the event, an FAQ, information on the speakers, and most importantly, the agenda. This year, we have sessions in English, Japanese, Korean, and Indonesian, divided into several tracks. Although the website does a good job of providing all the information you need, I wanted to see if I could build a chatbot which users could use to search through this information, and here's what I ended up with. As you can see, when I connect to the chatbot, it displays a welcome message telling me that it is a bot built to help navigate the agenda of this event. If I'm not sure how to continue, I can ask the bot for more information on how it works. The bot then provides more detailed instructions on what we can do. For example, it tells us that we can set our language preference, which I'll show you a little later. First, let's see how this works when I ask a question about the sessions. I'm going to be very self-centered here and ask the bot which session I'm presenting. It provides a link to the English language agenda because unfortunately there were no anchor points in the web page which I could use to link to the sessions directly. Then it provides the title of the session, the speaker, the level, and the duration. Finally, it asks if I would be interested in reading the synopsis of the session, so I can click yes, and it will then provide the synopsis for me. Another feature which I built into this bot is translation. So I can go ahead and ask the same question, but now in Dutch. Behind the scenes, the bot translates my message into English, finds the information, and then translates the output back into Dutch. If you don't speak Dutch, you'll just have to believe me when I tell you that this answer is correct. And this functionality works for any language supported by Amazon Translate. Now imagine we're interested in forecasting and we want to know if there's a session on this topic. You can see that the bot has indeed found a session. I happen to know that this session is presented in Korean, and although that's a lovely language, I unfortunately won't be able to understand it. So to prevent the bot from recommending sessions which I won't be able to follow, we can set my language preference. You can see that I ask the bot to change my language preference, and then I choose English because I don't speak any of the other languages available in this event. After I set my language preference, I try again to search for a session about forecasting, but we don't have an English language session on forecasting this year, so the bot doesn't find anything. Besides the agenda with all the sessions, I also built the bot to provide information on the tracks and session levels. So if we don't quite understand what is meant by a level 200 session, then we can simply ask the bot. And remember, we can do this in any language. So I can ask the same question in Korean and get an answer back in Korean. Finally, we can ask one of the questions from the event FAQ on the webpage, and we see that the chatbot is able to fetch the answer to this question for us as well. I have lots of ideas for other features which I could build into this bot, but let's leave it at this and look at how this was built. There are 4 main AWS services that I used to build the demo. To make sure we're all on the same page, I'm going to provide a quick introduction to each. Amazon Lex is a service for building conversational interfaces or chatbots using voice and text. It provides natural language understanding and automatic speech recognition capabilities so you can build chatbots quickly. To create a bot, you specify the basic conversation flow through intents, utterances, slots, and other features. Lex manages the dialogue and dynamically adjusts the responses in the conversation. You can build and test your chatbot in the console or through code, and then you can deploy the bot on mobile devices, web applications, and chat platforms. Lex has had lots of updates in recent months, including a completely new console experience and version 2 APIs. These were only announced at the end of January after I had started building the demo, so I haven't used them yet. But the new console should make it easier and more intuitive for you to build your bots, and the new APIs provide streaming capabilities. The changes also make it easier to build bots in multiple languages. Lex also provides native context management features now, where previously you had to create custom code to track context across a conversation. The express testing capability allows you to start testing your bot from the console before the build has even completed. In August last year, Lex received a significant update to its natural language processing models, which increased the accuracy of its intent recognition. At the same time, it became possible for you to see the confidence score with which Lex matches an intent. This is useful if you want to control how quickly Lex triggers a particular intent. Finally, Lex now supports a number of new languages, including different variations of French, English, and Spanish, as well as German and Italian. The second service is Amazon Comprehend. This is a natural language processing service which helps you extract insights from your documents. It has many different features, and I really recommend learning about each of them so you know when you can apply them to your use cases. But I only have time to provide a quick overview now. So with Comprehend, you can detect entities like person, organization, date, or quantity, and you can even train a custom entity recognizer to support entities specific to your use case. You can also use Comprehend to extract key phrases from your text, to identify, mask, or redact personally identifiable information, to determine the sentiment of your document, whether it's positive, neutral, or negative, to detect the language in which the document is written, and to extract the grammatical syntax of the words in your document. When working with a collection of documents, you can use the unsupervised topic modeling feature to divide your documents into groups, or you can train a custom document classification model to assign labels to your documents. There have been a couple of additions to Comprehend in the past months. One feature released around reInvent last year was Comprehend Events. You can see this as functionality that extends the entity recognition functionality because it detects events and how those events relate to entities. Although Comprehend does not generate a graph, I included a graph on this slide because that's the easiest way to understand what the events feature does. Right now, Comprehend can identify financial events like bankruptcies, mergers and acquisitions, or executive leadership announcements. Sometime before that, the Comprehend team announced a new feature for identifying, redacting, or masking personally identifiable information. It can identify personal names, bank accounts, usernames and passwords, and other types of PII data. Another feature announced last year was support for AWS Private Link, which means you can now secure your API calls to Comprehend from within your VPC and avoid using the public internet. And finally, Comprehend released a real-time endpoints for custom entity recognition last year. Up until then, you could only apply your custom entity recognition models as batch processing jobs. Not only can you now make synchronous calls, but the endpoints also support autoscaling since September 2020. The third service, Amazon Kendra, is an enterprise search service that enables your users to intuitively search unstructured data using natural language. Kendra can answer different types of questions, including factoid questions, meaning who, what, when, or where type questions, where the answer is usually a word or a phrase. But also descriptive questions, where the answer is a whole sentence, paragraph, or even an entire document. And finally, keyword searches, where you don't have a very specific question, but you just want a list of documents relating to those keywords. Kendra has been trained to understand language used in over 14 different industries and domains. And to use Kendra, you need to point it to a data source with documents for it to index. And to make this easier, we have many different connectors available, so you can connect Kendra to any place where you store your data. It's also possible to build your own connectors if none are available for your data source. Kendra has had a few updates, and I'm probably most excited about the incremental learning feature. It means users can provide feedback on the results in the form of a thumbs up or a thumbs down. And this is used to automatically update the underlying machine learning models. Since its launch, Kendra has seen a number of new connectors for data sources. It now supports ServiceNow, OneDrive, Salesforce, and Confluence, to name just a few. And I already mentioned before that you can develop your own connector if we don't have a pre-built connector available for your data source. The final service, Amazon Translate, does exactly what the name implies. It allows you to translate text from one language into another. The service is based on neural network technologies and supports a broad range of languages. Similar to Kendra, Translate is trained to understand the language used in many different industries and domains. It provides synchronous APIs for when you need your text translated quickly, as well as asynchronous APIs for processing large batches of documents. You don't need any machine learning expertise to use Translate because the models are all pre-trained, but you can customize the models to get even better results for your use case through custom terminology or through ActiveCustom Translation. So I just mentioned ActiveCustom Translation on the previous slide. This is a relatively new feature of Amazon Translate, which allows you to customize the translation results by providing translation examples. In addition to the custom translation feature, you can now also tag parts of the text so they will not be translated. This is useful for names of persons or organizations. And finally, Translate is now able to translate Office documents like Word, Excel, and PowerPoint. Hopefully, you now have a good understanding of the main AWS services I used to build the demo. The logical next step is to look at how I combine these services, so let's look at the implementation in more detail. Here is a high-level architecture diagram, which shows how the different components work together in the backend. It does not include the front-end components, which you can use to build a web UI for the user to interact with the bot. I'll talk briefly about the front-end later. So let's start at the right side of the diagram, where you see the developer. That's me. I needed to take the information from the Innovate webpage and transform it into a format which would be suitable for Amazon Kendra. In this case, I manually copy-pasted information from the agenda and the rest of the webpage into CSV files. But in a production situation, I would have built a web crawler to gather this information for me. I uploaded those CSV files into an Amazon S3 bucket. Next, I wrote some Python code which transforms my CSV files into a collection of text and metadata files for Amazon Kendra. The code uses Amazon Translate to translate the Japanese, Korean, and Indonesian content into English. Now, I ran the Python code from an Amazon SageMaker Jupyter notebook because I'm very familiar with using these, but you could run the code in any other compute service or even locally if you wanted to. The resulting files are uploaded into the same S3 bucket, and then I created an Amazon Kendra index using these documents. On the left side of the diagram, you see that the user of the web app interacts only with Amazon Lex. I'll cover the details of the Lex implementation later, but from this diagram, you can see that I built several AWS Lambda functions to add additional functionality to Lex. At the top, I have a Lambda function which fetches the synopsis of the latest result if the user has asked to see it. At the bottom, I have a Lambda function which sets the user's language preference. And finally, to the right, I have the biggest Lambda function, which takes a user query, detects the language of the query using Amazon Comprehend, sends the query to Amazon Translate if needed, sends the possibly translated query to Amazon Kendra, and then parses the results from Kendra and translates this back into the original language if needed. That covers it for the high-level overview of the implementation, but there are a couple of details which I think are worth mentioning. Now, Amazon Kendra specializes in providing enterprise search on unstructured or semi-structured documents. This just means that Kendra is best at search through documents written in full natural language sentences or paragraphs. My CSV files containing columns with information about each session don't really fit this description. So I took several steps to transform the data into a format which plays to the strengths of Kendra. First, I translated the content into English because Kendra currently only supports US English. Then I took the data for each session and inserted it into a natural language paragraph. So instead of just listing the title, I would create a full sentence which says, the session titled, insert title here, right? I hope you get the idea. This results in a text file for each session, track, level, and FAQ item. Kendra also has sophisticated tuning, faceting, filtering, and sorting capabilities, which you can use to adjust the results. These capabilities are based on the metadata of each document. So I also created a metadata file to match every text file. One of the metadata fields which I decided to add to each session is the language of the session. I can then later use this metadata to filter for sessions in English. Once I had all of those text files and metadata files, it was pretty straightforward to build a Kendra index on these files. Another thing I want to cover is how I used various features available in Amazon Lex to build the bot that you saw in the demo. What I use here is only a subset of the features that are available, so I highly recommend digging into the documentation to see what else you can do. Probably the most important feature for me is the ability to add Lambda functions for validating the user input or for taking action based on the intent. By allowing the integration of Lambda functions, Lex lets me customize the behavior of the bot through custom code, really allowing me to do almost anything I want as long as I can code it. For my demo bot, I used Lambda functions to parse user input and set session attributes like the language preference. And I used it to connect to other AWS services like Translate and Kendra. I just mentioned session attributes, which is another feature I used when building this bot. Session attributes allow you to store information throughout a conversation, which is how I store the user's language preference. Lex will remember this preference for as long as I want, and I don't have to ask the user for the same information over and over. I also use session attributes to pass information between two intents. For example, a user asking a question about the agenda triggers one intent, which queries Kendra and returns the top result. If the user wants to read the synopsis of the top result, this is implemented in a different intent, and that second intent has to know which result was returned most recently, so it can return the matching synopsis. I simply store the most recent result in session attributes to achieve this effect. Another feature of Lex which I use here is the fallback intent. When a user asks a question which Lex cannot match to an intent, it will trigger the fallback intent. So normally, you would use this to clarify what the user wants. In my case, I use it as a catch-all for the many different types of questions which need to be forwarded to Kendra. This means I don't have to predict the questions a user might ask. I can simply assume that if a user asks something the bot doesn't recognize as an intent, then this question is meant for Kendra. If you're familiar with Lex, you might know that Lex actually has a built-in Kendra intent. This intent behaves in a very similar way to the fallback intent and makes it easier to connect to a Kendra index without having to write any additional code. However, I chose not to use this specialized intent because it's only available in certain regions, and I wanted to inject my own code so I could call comprehend and translate before I called Kendra. Simply choose the intent type that's right for your situation. There are two more Lex features which I used in my bot. The first is message groups, which allows you to take a really long message and split it up into several smaller messages. The UI of a chatbot is designed around quick back and forth conversation. It's not for reading long novels. So the message groups just help to improve the readability if you do have a lot of information to share. The second feature I used is response cards. I really like response cards, both as a developer and as a user. As a user, I find clicking a button to be a lot faster than typing out my answer. And as a developer, response cards allow me to gather feedback from the user while restricting them to certain options. It makes it much easier for me to parse the feedback that I get. Finally, I wanted to quickly talk about the options for deploying your bot, since I didn't include this in my architecture diagram. Amazon Lex provides built-in deployment options for Facebook, Slack, Twilio, and Kik. It also integrates with AWS Amplify, which is a set of tools and services that help developers build front-end web and mobile applications. But in this case, I actually used an open-source UI implementation which is available on GitHub in the AWS-samples repository. This UI is very easy to set up in your account using CloudFormation, and it has a lot of nice features already built in. It's a great starting point for developing your own UI for Lex. So, if you're interested in building a similar chatbot, I have collected some resources on this slide, which I recommend you take a look at. There are a bunch of blogs with detailed explanations of how to implement each component I used, and there are some code samples to help you get started. I have included a link to the Lex Web UI here. You'll be able to get a copy of my slides so you can access these links. And that's all for my session today. If you want more content covering various machine learning topics on AWS, I recommend you visit the Resource Hub and browse through the material there. We also offer various digital training courses, classroom trainings, and certifications to help you build your machine learning skills. Definitely check that out if you want to increase your knowledge.